let's look at some word problems here. I see composite figures, compositions, compound figures. We have a greenhouse that has the given dimensions. How much glass is required to make the walls and ceiling? That's going to be a surface area problem. And what's the volume? How much air is in the greenhouse? So that's just a volume problem. All right, first thing I'm going to do, if we want to find out how much glass it takes, I'm going to break this up into two separate prisms. I am going to start with the rectangular prism on the bottom, and we want to know how much glass for the walls and ceiling. So we are ignoring the top and bottom here, right? Here's our base down here, and the top of our box there doesn't exist, and the bottom of our box sits on the ground, so we wouldn't make that out of glass. So all we need is the lateral area for that prism, which is perimeter times height. So if we look at our base here, even though we're not using it, we need the base for our perimeter. We want the perimeter of our base is, we'll just add up 14, 14, and 35, and 35. Our perimeter is going to be 98 feet. And the height of our prism goes from base to base. Even though we aren't using our bases and the top base does not exist, it's still where the base would be. So the height of our prism is 8 feet because we are measuring perpendicular base to base, right? All right, so we know the information we need. Perimeter is 98 times 8. So the lateral area of our rectangular prism is 784 feet squared. So that's our walls. Now let's do our triangular prism. This time our bases are on the front and back. Okay, so we need just these two bases and two sides, because once again this side over here does not exist. So this one might be a little more difficult. This one we need 2 times the base and then plus the left side and the right side. We don't need the back side. So this one's going to take a little more work. I think drawing a net on this one might be really useful. So we know we need these two sides. Doesn't have to be accurate to shape. And then we've got our two bases that go on it. Now what do we know? We know that that is 10. And where am I going to get these other measurements? Well, this one's 10 as well. And this is going to be 35. So that means this side is 10, this side is 10, this side is 35. And we don't know this length right here or the height of our pyramid. But you know what? I see an isosceles triangle right there. What do you want to bet that we can find those measurements? Okay. So, oh, wait. We do know. This right here, we do know that. That's 14. So we know the base of our triangle. That's a start. So let's draw our triangle here. We're going to need our bases, 10, 10, and 14. And what do you want to bet that we are going to draw a right triangle? This becomes 7. I see Pythagorean theorem, a squared plus b squared plus c squared. So we're looking for height. Don't forget we're only using half of that base. plus, subtract 49 from both sides, and h squared is 51. So we know that we need to square root. So height equals the square root of 51. It's really the best we're going to do on that. And we also know the base equals 14. So we can now find the area of our base. So let's do that. The area of the base is just 1/2 base times height, right? Area of a triangle. So that's 1/2 times 14 times the square root of 51. Okay, so the area of the base is 7 square root 51, and what you need to learn, feet squared, and we need 2 of those, so 2 times the base is 2 times 7 square root 51, so that equals 14 square root 51 feet squared. Right, there's my front and my back. And now all I need to do are my 2 rectangles here. So I have a rectangle that is 14 by 35. So it's 14 times 35. So the area of this one is no, that's not 14. It's 10. By 35. We've got a problem in our drawing here. This side is 14. This is 10, which makes our base go that way. Alright. Because we're looking at these sides here and this side over there. So they are both going to be 10 by 35. Alright. Got to be careful with this stuff. So it's 10 by 35. So that's 350. Okay, and we have 2 of them. 2 of them. So 2 of my sides. My left side and my right side are the same. So is 2 times 350. So that equals 700 feet squared. So I now have my sides, the front and back of my roof, the triangular pieces, and the 2 top pieces of my roof. And so my surface area of the windows and ceiling is going to be 784 plus 700 plus 14 square root 51. So I could put that in terms of 1484 plus 14 square root 51 feet squared, or a much better number would be to put that into my calculator. (1484) plus 14 square root 51. Trusty calculator says that that is 1583.98 feet squared, so that would round up to 1584 feet squared. Any one of these answers is good. So a little bit of work there, a little bit of mistake along the way, but that's how we learn. We go back and check and make sure it's all matches up with our diagram. That's why we draw and label everything. So that was a little bit of effort to get through. Let's take a look at the next one. All right. right, last problem here. It's been kind of a long review. A conical ice cream cone, okay, has a diameter of 3 inches and a height of 5 inches. It says how much waffle material is needed to make the cone, so that's surface area. And a scoop of ice cream has the same diameter as the cone. How much ice cream do you get? That sounds like volume. If the ice cream melts, will the cone be able to hold it? Ooh, we are going to need the volume of our ice cream cone as well. So this is the volume of our ice cream, surface area of our cone, volume of a sphere. And if not, how much do you need to eat? That's just going to be subtraction after we compare the two. And what is the maximum diameter of the ice cream scoop that will fit into the cone when melted? That looks like a problem that we are going to have to find at the end. Okay, well, let's start here, of course, with a drawing. An ice cream cone, and I know diameter, D equals 3 inches, and I know height. Height goes this way. Height of my cone is 4.5 inches, and rarely do we ever use diameter. We need radius, so radius is 1.5 inches. Okay, lots of good stuff going on there. What are we doing first? We want to know how much waffle cone. So that sounds like surface area to me. And surface area of a cone is pi. Actually, we don't need surface area, do we? Our ice cream cone does not have a top on it. All we are interested in is the lateral area. So this is just the lateral area here. Lateral area of the cone is pi r L. And I do not have a slant height, so I'm going to come over here and I'm going to find my slant height. And I have my triangle. And now this is 1.5 because all I'm looking at is this triangle here. And this is 4.5, and I am looking for L. So this is simply a matter of Pythagorean theorem. A squared plus b squared equals c squared. Hypotenuse is always c. So 1.5 squared, 4.5 squared, L squared. This is 2.25, and 20.25 equals L squared. So L squared equals 22.5. We know how to get rid of square root or square root. So L is the square root of 22.5. Okie dokes. Let me just substitute in. So this is pi, radius is 1.5, slant height is the square root of 22.5, so lateral area, let's put that into our calculator. We might as well go out and decimal 22.4 inches squared because this is an answer. That's how much waffle material we need. All right, and a scoop of ice cream has the same diameter as your cone. So I have a scoop of ice cream. So we know the radius of this is 1.5 inches. And we want to know how much ice cream we get. That's volume. Volume of sphere is 4/3 pi r cubed. Substitute in 4/3 pi 1.5 cubed. That just goes into the calculator. The volume is 14.1 inches cubed. That's how much ice cream we get. And if it melts, will it fit in the cone? Well, we are interested in the volume of a cone. So the volume of a cone is 1/3 area of the base, which is just pi r squared, times the height. We have all this information. We substitute in radius 1.5 squared. Height of our cone is 4.5. And the volume of our sphere over here, volume of our cone, put that into our calculator, we get 10.6 inches cubed. So now we compare these two. No. It will spill. By how much? Well, that's simply just subtraction. 14.1 minus 10.6 tells us that we need to eat 3.5 cubic inches of our ice cream for it not to spill. Now the last problem says, well, if we want our ice cream cone to be able to hold all of our ice cream, what is the maximum diameter of our ice cream scoop? So how are we going to figure that? Well, we need to use the volume of our cone. This is going to be our max volume. So we are going to take that, and we know that the volume of a sphere is 4/3 pi r cubed. Our maximum volume is 10.6, is 4/3 pi r cubed. Okay, then we are going to multiply by 3 over 4 on both sides. Divide by pi, divide by pi. All of these cancel out. And we get our cubed equals 3 times 10.6, all divided by 4 times pi. Put that into our calculator, simplify out our numbers. 3 times 10.6 divided by 4, enter. This is 7.95 over pi, and we need to cube root. So we know that r equals 7.95 over pi to the 1/3, and then that just lets me find my maximum volume. Oh no, we don't want volume, we want diameter. Erase. So max diameter is just d is 2r, so that's 2 times 7.95 over pi to the 1/3. I'm going to throw all that in my calculator. Divided by pi raised to the 1/3 power times 2. And our diameter max to melt into our cone is 2.72, and our unit is inches. So we need a little bit smaller ice cream cone. We had a 3-inch ice cream cone that didn't fit in our cone, or we need a taller cone. Either way. All right, those problems were a little bit challenging. Just do them one piece at a time. Anytime you have word problems, you know that you're going to have to break it down into one piece at a time, figure out what it is that you need. Be careful when you are doing ratios or comparing your surface area and volume to find radius. Be careful with square rooting, cube rooting, squaring, and cubing. Your calculator knows how to do it as long as you put it in correctly. Use parentheses, draw and label everything, and then use your formulas. One formula at a time. All right, well, that is the end of chapter 11.